Welcome everybody, it's Ramchandra from Civil Mech Maths Concepts channel, and it is in integral calculus 4th video dealing with the continuous functions and discrete functions, step functions, Dirac delta function, and how to apply the integral properties in addition to the continuous functions of dx, how to apply them to the box functions like d box x, that is smallest integer functions and also other functions, so that integral calculus can be easier for everybody. Welcome everybody to the channel Civil Mech Maths Concepts. It is Ramchandra again from Civil Mech Maths Concepts. This is the 4th lecture on integral calculus. Integral calculus lecture number 4. Why I am stretching more on integral calculus? Because it is the basis for differential equations and also Fourier series, Laplace transformations, Bessel functions, and even for day-to-day engineering applications. The basics in integral calculus are very, very important. In the last class, we have seen that a sum of series can be represented as a definite integral, like limit p tends to infinity sigma p is equal to 1 to n 1 by n function p by n is equal to integral 0 to 1 function x dx. And I have defined what is function x, which is nothing but function p by n on the left hand side. What is dx? It is nothing but 1 by n. What is integral 0 to 1? It is nothing but sigma p is equal to 1 to n limit p tends to infinity. This is what are the definitions in the above function. Now, to understand better the definite integrals, we require little bit of basic properties to be understood in integral calculus. The first basic property is an absolute value of integral a to b of a function f with respect to dx is equal to or less than or equal to integral a to b absolute value of function dx. The proof of this you can get from any standard book. Please try to understand that the absolute value of the definite integral a to b of a function dx is less than or equal to integral a to b absolute value of function with respect to dx. The next property we can write integral a to b function dx is equal to integral a to c function dx plus integral c to b function dx. Another important property, we always see that we get a single variable like dx, dy, dz, dp, dq. But if there are a combination of variables with respect to which an integral is to be integrated, a function is to be integrated, in that case what happens? Integral a to b function, it is to be integrated with respect to dp plus q. That means it should be integrated with respect to some of the different variables. In this case, it can be written as function a to b, integral a to b, function dp plus integral a to b, function dq. And another thing, instead of addition, it is a multiplication with a scalar. Integral a to b, function d of px is equal to p into integral a to b, function dx. These two are very, very important properties. Other important property is only from the absolute value theorem, that is inequality. Whereas these two are very important. These two, then I thought these four, let us know them before going further on integral calculus. Now, we have seen in Leibnitz theorem or other theorems, there is a differentiation also embedded in the integration. In that case, what happens? This is another important theorem. Integral a to b, function integrated with respect to p dp is equal to integral a to b, function p dash p. Whereas this function f is continuous in closed interval a to b, and p dash has a derivative and continuous. Derivative is continuous in closed interval a to b. This is also very, very important theorem from integral calculus. Now, we have seen everywhere in normal integrals, it is given that a function is given, and that function is asked to be integrated with respect to dx, or a function t is given, asked to get differentiation with respect to dt. A function u is given and asked to differentiate with respect to u, or some of the functions, some of the variables, as seen in the previous 5 properties. These are important properties. I have not gone into the definitions and simple properties, where you can very well refer from your textbooks. Whereas these are the properties which require your attention and which are useful for higher integration processes. Now, let us see. If a function is given and if you are asked to differentiate with respect to not dx, but with respect to d box x, where box x is equal to smallest integer greater than or equal to x. For example, what is the value of integral e to the power of x dx from 0 to 3? This is nothing but e to the power of x and between limits 0 to 3, because it's a continuous function. It's a continuous. Please understand continuity. Please remember continuity. It's a continuous function. We have this value. Then it will be e cube minus 1. This is the value. The value of integral 0 to 3 e to the power of x integration with respect to floor function x, or we can say box x, or we can even say the smallest integer greater than or equal to x with respect to. This will be e plus e square plus e cube. You see the difference between the values. This value differs from this value. With ordinary dx, it is e cube minus 1. With the smallest integer function dx, it is e plus e square plus e cube. Why the difference is there? We'll discuss. If you see, I have given a property. Integral a to b, third property, if you see, have a glance. Integral a to b function d of p plus q is equal to integral a to b function dp plus integral a to b function dq. Then let us go with a small example. E to the power of x, we got the values. I'll explain how these values have been obtained. Let me go with a little simpler problem than this. Integral 0 to 5 x dx. What is the value of it? X square by 2 integral 0 to 5, that is equal to 5 square by 2 minus 0 square by 2, that is 25 by 2, that is 12.5. Now, what will be the value 0 to 5 x d with respect to smallest integer function? Will it differ from the regular value? Yes, it differs. How it differs? Why it differs? Once we know for a small function like x, d box x, then we can expand it to other functions also. Now let us see. Integral 0 to 5 x d box x is equal to this d box x. Why I am spelling or pronouncing like this? For the convenience of all of you. I can every time if I start saying smallest integer function means you may get confused. My nomenclature may not be textbook nomenclature, but I only simplify the things so that you can better understand the concepts. Now, what is the value of 0 to 5 x dx? x d box x. Whereas in the continuous function, it is an antiderivative. In a continuous function, it is an antiderivative. Whereas in the box functions or smallest integer functions, differentiation with respect to them, the values have to be summed up for every smallest integer function as per its definition. That means it's not like a formula, it will be like this, where I have shown you in the first sum of a series. Then it will be a sum of a series of x, whatever function x you say. Here it is x. Sum of a series of the function x such that the values change. The values change as per the smallest integer function. These values will be from n is equal to 0 n is equal to 0. Please think over. I have given a minute for you to think over. To 4, n minus 1. Rather, I can say it is not 4 or 5. We can say because it is 5 here, it is 4. Now, with this in mind, you tell me what will be its value. I have reversed the definition. Integral 0 to 1 function x dx is equal to limit so and so sigma 1 by n function p by n p is equal to 1 to n. I have removed all the limits. For smallest integer function, the formula is this. This rather I can say this can be function x. This can be function x. Now you tell me, what will be the value of 0 to 5? This will be function 0 plus function 1 plus function 2 plus function 3 plus function 4. Now you tell me, what is the value of 0 to 5 x dx? It will be, this is the function x. Here in this problem, and function x will be, function 0 will be. What is the function 0? This is box x, because we are doing with respect to box. The smallest integer greater than 0. That means it is 1. With respect to box x, we are doing the integral value. We are calculating the integral value. Then function 1 will be, it will be smallest integer greater than 1. That is 2. Function 2 will be smallest integer greater than 2. That will be 3. Function 3, it will be smallest integer greater than 3, that is 4. Function 4 will be smallest integer greater than 4, that is 5. What is its value? 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Same problem if we do with x dx, it will be x square by 2, value 0 to 5, it's a continuous function, that is equal to 25 by 2, that is 12 point. Both these values differ. Try to understand the concept. Now once you understood this concept, then can you calculate 0 to 5 e to the power of x t box x, the smallest with respect to the d of smallest integer function or a ceiling function? Then it will be, this is function x, then for function 0, it will be e to the power of 0. But what is the value of x with respect to the smallest integer greater than 0? That means it will be, the value will be e to the power of 1 plus e to the power of x value. What should be the x value? What should be the x value? The x value should be smallest integer greater than 1 here, that is 2, plus, because you please try to understand this, x value is box x, that is smallest integer greater than x. Then here it will be smallest integer greater than 2 and smallest integer greater than 3. And smallest integer greater than 4. Now you got the difference. Similarly, if it is a continuous function 0 to 5, e to the power of x dx is equal to e to the power of x 0 to 5, that will be e to the power of 5 minus 1. Whereas if we use the smallest integer function, it is like this. The value is like this. Now, homework. Please do this homework. Please do this homework. I will give a hint, but you do this homework. Integral 0 to 6 e to the power of x d of x minus smallest integer x is how much? Kindly solve this. Kindly solve this problem. I'll give the hint. Hint is integral 0 to 6 e to the power of x d of x minus smallest integer x is equal to integral 0 to 6 e to the power of x dx minus integral 0 to 6 e to the power of x d box x. This has come from the property 3. Integral a to b f d p plus q. Integral a to b, a function d with respect to p plus q is equal to integral a to b f dp plus integral a to b f dq. In GATE examination or higher engineering mathematics examinations or IIT advanced mathematics question papers or CSIR or UPSC civil services, it's not about how complicated the question is given. It is about how the question is given with a number of concepts involved in it. The number of concepts involved in it. You see, in this question, the properties are involved. The definitions of the ceiling function or the smallest integer function is involved. It is also involved. It's also involved. And also, the regular is also involved. The regular interval. The regular integral. That means in an integral calculus, the different definite integral questions can be given by using the properties so that never get confused if the values are given in box x with respect to box x or with respect to any other regular dx. Now, can you tell me, let us derive from this another property. Mathematics is an innovation, creativity. Let us derive. Now, I understood the box x function or smallest integer function. Let me do something. For example, the same, can I write like this? Integral a to b, some function is integrated with respect to d p minus q. Can I write? We can write a to b. It is function dp minus integral a to b function dq. It may look very simple, but let's work on it. Now let this function is not ordinary function like x minus box x. Let us say this d of function is absolute value of p minus q. Then in that case, what do you do? Then you have to split this differentiation operator or dx or d of absolute p minus q into two step functions. This will be, what is p minus q absolute? It will be p minus q if p minus q is positive, there is no problem. P minus q is greater than or equal to 0. It will be minus p minus q if p minus q is less than c. This is the meaning of p minus q absolute value. That means d absolute value of p minus q is not simple as d x minus box x or d pi minus q, where p and q are different. When you put the absolute, then definitely there will be something different, and we have to do the integration in step, and we have to add these integrations, and we have to find the final answer. Now, I will give a homework involving all this. Please do this one question correctly. Then your smallest integer function or ceiling function and the value of dp minus q, the concept of dp minus q will also be totally cleared. And for these two, the basic questions I have already done. Please do homework. What is the homework? Find integral 0 to 10 x square plus 2x 2 box x, let us say, plus 1. This is the function. And do the integration with respect to 7 minus x absolute value. It may look difficult, or it may look complicated, or it may look complex when you glance it. But I'll give two hints. This is the smallest integer function, and this has two step functions. You have to divide into two step functions, and then apply the theorem of d p minus q is equal to dp minus dq. And for this function, smallest function, you apply, this is function x, and this is differential operator or integration, with which this differential operator you will be doing the integration, antiderivative. Then use these concepts which I have already explained. Done. Example questions. If you do this particular question perfectly and show it geometrically, you can very well get the concepts very clear in your mind, and you will be able to understand the smallest integer function and also integer operator dp minus q, and any type of question that is given from the concepts, you will be able to solve them. It's not about the complicated, complex questions being given in GATE or IIT Advanced, or it's not about questions in CSI or complicated questions. These concept-based questions have more importance and more questions are being asked on these concepts rather than formula buttification questions. Now, can we go little further? That is a little bit of, I can say rather, substitution. All you are aware of the substitution problems. When you put something like substitution, everything is based on the properties which I have discussed. 1 to 5 properties. Like fourth property, substitution. Fifth property involving differentiation. And third property I have fully, exhaustively, I have explained to you. Now, we'll move on to, for example, let me say, can you find out something like this? 0 to 3 x cube dx cube. Integral 0 to 3 x cube dx cube. This also you try. That means d need not be dx only. It can be anything. I can differentiate a function or I can integrate a function with respect to anything. That's what is called as a substitution. And with the help of substitution, you can find the definite integral values and you can apply 5 theorems which I have told. There may be many theorems on the integral calculus, but I picked up 5. These 5 I think they may come regularly in the competitive examinations of higher mathematics level. Let us solve one small problem with step functions, definite integral to be used for step functions. That problem is given in GATE 2024. The question is indirect. Very simple question. When you understand the step function, when you understand the integrals, it will be a very simple problem. Can be solved in 30 seconds. Less than 30 seconds. Let's go for a problem. It is given a continuous random variable. Continuous variable is defined. What is that? Continuous variable. Continuous variable means we can use ordinary dx. Continuous variable within the interval, closed interval 0 to 1. But the probability function is a probability function. What is function x? Probability function x. It is given as a step function. It is 1 for 0 less than or equal to x less than or equal to 1. 1 and the value of function x is equal to 0 otherwise. The value of function x is equal to 1 for x less than or equal to 0 or less than or equal to 1, and the value of function x is equal to 0 otherwise. Function x is given, interval is given, and continuous variable is given as a continuous variable, and y is equal to given as ln x plus 1. It is asked to find out the expected value of y. What will be the expected value? Expected value is nothing but, in a probability, the limits of definite integral may vary from minus infinity to plus infinity. For 0 to 1, x less than x greater than or equal to 0 and x less than or equal to 1, zero to 1. That is how function is defined, and its value is ln function x value for 0 to 1 is 1, ln y value is ln 1 plus x, and simply dx. That's all. This value is integral 0 to 1 ln 1 plus x dx. That is equal to, substitute the values, and find out ln 1 plus x, and you get the value of it as 0.39. Do it as homework. Remaining steps. That means you just see. A question on this can be given as a continuous variable dx defined between 0 to 1 closed intervals, and the value of the function x, step function, is given, and step function otherwise is 0. Hence the value of y into function x will be 0 for otherwise. Then we have to consider only 0 to 1. Within that you calculate ln 1 plus x dx, and you put the interval values, you get the value as 0.39. This is how the problems can be solved by using this. And instead, for example, instead of a step function, something is given in differently, then you can apply the same principle. Usually this type of problems, they take the graph like this. A question can be from graph also. They will take the values like this. This is minus infinity, this is plus infinity, and these values 0, and the values of x will be after certain limit. The values of x will be, usually it is called as 95% confidence level. I can treat this can be some frequency distribution curve. If you go for 95% confidence level either side, then this portion, why I am telling this, 95% confidence level usually is used in engineering designs. This is the probability that value falls within this, and maximum probability. Here the expected value is 0.39 if it is from 0 to 1. If it is from 0 to 1, this is 0 and this is 1, let us say. The probability will be this, the expected. How, and this is how we geometrically see the integration. Even Dirac delta functions is there, for which the function moves like this, minus infinity, plus infinity. Suddenly, after moving like this, suddenly it takes a unit value and suddenly drops. This particular point is the point of concern. In Dirac delta function. Why I told this? The step functions are usually the confused functions, and how to represent a step function and how to integrate them, how to get the values. This is one of the challenging tasks for engineers who are appearing for GATE or higher engineering examinations. Step functions are nothing but define a function from this range to this range. That function is defined by certain parameters, and from one range to another range, other ranges, it is defined in other manner, and the integration to be done. As in this case, the integration is done from 0 to 1 only, because otherwise the value of the step function is 0. The real value of the step function, where it has certain value, that is from 0 to 1. That 0 to 1 we have defined and we have got the expected value, and we have got the question solved within seconds. It's nothing but applying the basics everywhere, not by hearting the complex formula. And once again I am telling you, applying the basics, not by hearting the complex formula. This, why I have taken this additional functions and additional definite integral properties and additional questions on different functions like small integer functions or ceiling functions, and probability questions with step functions. Why I have taken this? Because if these concepts are very, very clear in your mind, then in the next class we will go for Leibnitz theorem, and I give a little bit of introduction to Dirac delta function also. It is not there in your syllabus, but we can't say what is calculus. In the wider range, they may ask a small definition or a very simple problem on Dirac delta function, because they have given the step function here, probability. In probability, we can expect a small question on Dirac delta function in the future examinations. Now with this, I will conclude today's session. In the next session, we'll talk about the Leibniz theorem and also a little bit of Dirac delta function. Then we'll move on to differential equations. Modeling with differential equations, mathematical modeling with differential equations. Once we start with mathematical modeling, that is called mathematical modeling. Differential equations. We can parallelly understand the physical meaning and ordinary differential equations and partial differential equations. Instead of by hearting the formulae, we will be moving towards modeling. Once we model a physical model, we will understand, we can understand the mathematics behind it very easily. For example, prey-predator model, natural model, water tank emptying model, that's also a natural model. If we talk about the prey-predator model, there are animals which feed on animals. There will be addition of animals. There will be reduction of animals. Flora, fauna. In nature. These are all models. Prey-predator model. From this, we can find out over a century or a million years from now what will be the status of the flora fauna, what will be the status of the different species on earth. These expectations, these can be found out with the help of the differential equations. Let us take a tank. We are pouring water in it at the rate of m dot. Mass is pouring in, or q dot. Water is pouring in, liquid fluid is pouring in. Then something is coming out. This is m dot in or q dot in. Something is coming out as m dot out and q dot out. And the level is h, initial level. And it's reducing with time, dh by dt, something. M dot is dm by dt, something. Q dot is dq by dt, something. And this in, with conservation of energy, conservation of mass, conservation of momentum, we'll find out a model wherein this goes into a differential equation, and we'll try to solve that one-dimensional differential equation with the help of the boundary conditions defined at the beginning of the problem. Initial boundary conditions. And we'll try to solve. This is the idea of the modeling. Once we get an idea of the modeling, then the differential equations will be solved automatically one by one without any much complexity. We'll try to understand the mathematical modeling also. Next lecture will be of Leibniz theorem, something about it, because in IIT Advanced 1 or 2 times in definite integral questions have come from Leibniz theorem. Then Dirac delta function, only to make you understand the probability expected values and little bit of quantum mechanics. And then our main thrust will be towards mathematical modeling and differential equations from next class onwards. Best of luck to everybody. Thank you for listening to me, and I have already released 3 lectures on integral calculus. It is the 4th lecture. In total, I released 13 lectures. If you feel that my lectures on linear algebra and integral calculus are good for you and give a value addition to you, please subscribe to my channel so that you will get the regular updates about the videos being released by me. Best of luck to everybody. Thanks a lot. It's Ramchandra again from Civil Mech Concepts, and the mathematical concepts are being given by an IIT alumni. I am an IIT alumni. Best of luck. Thank you.